All right. We're good?
We're good.
Hey, all right. Good morning, class. We're going to be talking about the conservation of energy this morning and discuss what that means and how it applies to today's lab and also various scenarios here. So the conservation of energy, when you hear conservation, it means that before has to equal after. So before equals after. Okay? And sometimes you may have heard conservation of energy being described as energy cannot be created or destroyed. You ever heard that? Okay. Now, what does that mean mathematically? So what that means is that you have up here what we call the starting or initial potential energy plus any initial kinetic energy, okay, minus any work done by friction or heat. Okay. This has to equal the final kinetic energy plus the final potential energy. Okay. Now, what does this mean? Now, if I rearrange it like this is starting potential energy plus starting kinetic energy. I'm going to bring this over to the other side. So what happens is that this is the final kinetic energy, the final potential energy, plus any work done by friction. Okay? So what this means is that if you go out on an evening, like Friday night, you want to go to the mall or go to the movie, your mom gives you $100, that's all the money you have to use to spend. Okay? So what happens is that what this means is that this here is your starting energy. Okay? This is starting. Okay? It could be, this could be zero, it could all be potential, it could be a mix of this, or it could be this, but this is your starting energy, okay? All that you have. This has to be distributed to final potential, final kinetic, or any loss of heat. So your starting energy has to be going here, here, or here, and that's called the conservation of energy. So whatever energy you have to start with must be what you end up with. Now, this here, this is called heat. Okay, try rubbing your hands real quick. You feel that heat there? If you could capture that heat and make it do work, like turn a turbine, you'd have your picture next to Einstein. It'd be Newton, Einstein, Ramirez. Okay, if you could do that, okay? Now, this heat is what's called unusable energy. This cannot be used to do work, like turn a turbine to make electricity. If we could, then that would solve our energy problems. All right, so this is conservation of energy. Pause.